you're enjoying your day. I thought that maybe we would work through this morning the extra practice sheet that's in your packet. So it should be the very last page of your packet. And it is the sheet called Extra Practice 1.5 to 1.7. So Extra Practice, last sheet in your packet. And we'll work through that this morning as one last opportunity to practice before our test. All right, so number one, here we go. Once again, we're on the extra practice sheet. Last page in your packet. Here we go. Problem says this, and we are going to find the inverse and its domain. All right, we can do that. So first of all, I'm going to switch my variables. Remember, that's y. So I'm going to switch my variables. Now I'm going to get rid of that fraction, so I'm going to bring this over here and distribute. Now notice I'm supposed to be solving for y, but I have two y's. So I'm going to put them on the same side. Doesn't matter which side. Your answer will look a little different if you do it on a different side than I did, but you will still get a correct answer, so don't worry. Move all the y's to one side, and then factor them out. So instead of having two y's, now we have just one y, and then we'll divide by that parentheses that we created when we divided, or excuse me, when we factored. And so our inverse is this. Now your job, besides finding the inverse, and that's the inverse, your job is to find the domain of that. Okay, remember, domain is influenced primarily by two things, radicals and variables in the denominator. Obviously no radicals. But we do have a denominator, so we know that 3x minus 4 cannot be 0, so 3x cannot be 4, and x cannot be 4/3. That is the domain of your inverse. Now, I'd like you to notice that back in the original problem, okay, this is just a little aside. I want you to think about this. Back in the original problem, the horizontal asymptote was 4/3. In other words, y couldn't equal 4/3. There was an asymptote there. Well, when you switched the variables, what y couldn't be in the original is now what x can't be in the inverse. Pretty awesome. All right, I've got a couple of things that are supposedly inverses. Somebody's done the problem and said, okay, these guys are inverses, prove it. Remember, when your job is to prove that two things are inverses, you must build them in composition. So we're going to do f of g and g of f. Remember, f of g means plug g into f. So we're going to take whatever g is and plug it into f. So instead of that x right there, we're going into f. We're plugging into f. So instead of that x, we're going to put in g. Now, the 4's are going to cancel, and we're left with x plus 2 minus 2, which is x. And remember, if you are proving things are inverses, you have to, when you build them in composition, you have to end up with x. We did. Now we got to do the other one too. If you want full credit, you got to do them both. So now we're going to plug f into g. So we're going to take the f function and put it into g. So we have 4x minus 2 plus 2 over 4. Well, minus 2 plus 2 cancels, We got 4x over 4, which is x. That's your proof. That's what you have to do when the directions say prove that two things are inverses. All right, now we're going to do some sketching. So you've got the original, just like I do, right there on your paper. So I'm not going to draw the original. I'm going to draw the absolute value plus 1. Now, you know, I've told you often enough, I can't do this in one step. So I'm going to take it a step at a time. Certainly, you are welcome to do it in one step if you can. That's absolutely fine. I just can't handle it. So I remember that when I sketch the absolute value of the whole function, when I do the absolute value of the whole function, everything that was positive stays positive. So that guy's staying there, and this guy's staying here. That part is not changing. Everything that was negative, so the original picture had this V down here, those points are getting flipped up. So instead of going over 2 and down 3, I'm going to go over 2 and up 3 and draw my triangle like that. So that is a picture of just the absolute value. That's the absolute value. Now I have to take that absolute value and add 1 to it. And you remember that adding 1 to the end of the problem means move it up. So we're going to move everything up 1 unit. So everything's going to be 1 higher than it was before. So I'm going to erase this so you can clearly see that is the answer to the question. I don't think I gave you the answers to these, so it's good we're doing it. Okay, now the next one says sketch 2f of negative x. Well, again, this is a two-stepper. There's two things going on. I might be able to do this one all together. I don't know. It's a little confusing for me. But I might be able to. Okay, so here we go. Got to remember what these things do. This 2 right here makes me twice as tall. That's the vertical times 2. That affects the vertical, multiplies the vertical, so everything's going to be twice as tall. And then this is across the y-axis. So it's a sideways flip. This is a sideways flip. So I think I'm not going to try to do it all at once. I'm going to do it one at a time. So I'm going to do my sideways flip first. So everything that was on, look at the original picture, everything that was on the right is now going to be on the left. So I'm going to, and I'll do it dashed, I'm moving everything that was on the right over to the left, and then I'll move everything that was on the left over to the right. So I hope that shows up on the video, the dashed line. That is this part of the problem. That is the reflection across the y-axis. Now I'm going to take that guy and make him twice as tall. So this right here, instead of just going up 1, he's going to go up 2. So that triangle is going to look like that. This one's going to go all the way up to 4. And this one's going to go all the way down to 6. So I'll take my dashed line out of there. And that is the answer to the question. So we reflected it sideways, flipped it sideways, and made it twice as tall. All right. Now what's going on? Well, again, there are two things, so I'll take care of one at a time. All right, so here we go. This guy divides the horizontal. So basically, I'm dividing by a third, which means I'm actually going to be 3 times as wide. Really stretched. And that turns me upside down. That's a flip this way. This was a flip this way. All right, so I'm going to do this part first. I'm going to do my stretching 3 times as wide. So my initial triangle, oh my. I'm going to run out of room here. Oh, I know what I'll do. I'll just put more marks in there. There we go. Problem solved. All right, so here we go. We're going to stretch this thing 3 times as wide. So that first triangle, which is up 2, is now going to be 6 wide. Now it's going to be hard to tell because I made my hash marks closer, but this is now 6 wide. Still too tall, but 6 wide. And then the next one is also going to be 6 wide, but only 1 tall. So again, this is really, really stretched, but because I ran out of room over here, I squished things up a little bit. But that's 6 units wide and another 6 units wide. And then this other triangle now is going to be 9 across. He's still 3 down, but he's 9 across, so he's wider too. And that's the picture of this part right here. Now, I'm going to take the thing I just drew and I'm going to flip it upside down. Now erase the original. And there we go. So there is a picture stretched 3 times horizontally and flipped upside down. Okay, now we got one more. This one, luckily, only has one thing going on. We're taking the absolute value of x. Now remember, when you take the absolute value of just x, everything on the right side stays the same. So I'm going to have my little triangle over here. It's going to stay exactly the same. That guy and that guy. The right side of the picture, whatever is on the right side of the picture stays exactly the same. And then it gets reflected sideways across the y-axis. So you would have this. That is a picture of f of the absolute value. Remember, when you take the absolute value of just x, everything on the right stays the same, and the right gets reflected onto the left. Okay, now number 4, go back to the original picture, and let's just make a list of what changes have been made. So if you look at that picture, I see there are quite a few changes that have been made. First of all, it looks like it has been reflected or flipped across the y-axis. Would you agree with that? That we're flipped across y? What else has happened? Okay, so imagine flipping across y. Looks like we have also lifted it up too. Is that all? I think so. We just flipped it across and then raised it up too. So I think we're good. So now we're going to write the equation. We have y and f of x. What accomplishes those moves? Well, raising it up to, you know, is a +2 on the end. What flips it across the y-axis? If you want to do a sideways flip, you got to put the negative on the x. So there's the equation that would generate this picture. If you want to check that, just graph this. Just graph that, like we've been graphing these other things. Graph that and see if it ends up with what you have there in number 4. Number 5 says describe in words. So you're not right. In this problem, we wrote an equation. In number 5, we are describing in words the transformations required to take the parabola. Okay, so F, I want to get a visual of where F is. F is left 2 and down 4. So here's that one, left 2 and down 4. There's F, that's a picture of F. And then G is right 3 and up 1, and it's upside down. Okay, so look at number 5. Look at F, parabola F. It's parabola. It's moved 2 units to the left and 4 units down. G is also a parabola, but it's moved 3 units to the right, up 1, and flipped upside down because of the negative out in front. All right, so now we got to talk about how we're getting from this spot to this spot. Well, we got to do a couple of different, actually we do have to do 3 different things. We have to move it in the x direction, we have to move it in the y direction, and we have to turn it upside down. So we have to reflect across x-axis, or if you want to say turn it upside down, that's fine. Turn it upside down, that's fine. You have to turn it upside down. That means a reflection across the x-axis. That means a negative out in front. Now we have to get from this x to that x. So we're going to move it how far in the x direction. We're going from -2 to 3. So we're going to move it 5 units, right? Because we're going from -2 to +3. And then we got to go from -4 to +1. So coincidentally, we're going to move it 5 units up. To get from function f, from parabola f to parabola g, those are the changes that we would have to make. All right, now we got a set of parametric equations, and we're going to write a single Cartesian equation. So here we go. Got to solve for t. Probably easiest to do it in that top one. So let's see, if I solve for t up there, I'm going to be careful. Looks like t equals -x plus 2. So I'm going to take the, or if you want to write that as 2 minus x, that's fine. Same thing, 2 minus x, -x plus 2. Now I'm going to put that in my equation here. So I have y equals 1 plus 2 minus x squared, which is 1 plus 4 minus 4x plus x squared if I do my foiling. So the answer is going to end up being y equals, okay, so here we go, x squared minus 4x plus 5. And there is your equation, your Cartesian equation that describes or that represents those two parametric equations. So we've got t by itself and substituted that into the other equation and have our answer. My allowance is $2.50 a week. I spend 49 cents on a stamp. What percent of my allowance is spent on postage? What percent of my allowance is spent on postage? So that would be 49 cents divided by 250. I'm spending 49 out of 250. Notice it's 0.49 because it's 49 cents. So 0.49 divided by 250 is 19.6%. So 19.6% of my allowance is spent on postage. Okay, now we're mixing orange juice. So I'm gonna, anytime I have a mixture problem, I'm gonna do amount times percent plus amount times percent equals amount times percent. That's just the way I'm gonna do it. So what are my percentages? Let's put those in first. So I have 0.73 orange juice. I have 0.34 orange juice, and I want to end up with 0.60 orange juice. The only amount I know, and remember you always know one, the one you know is the 34%, and that's 20. We have no idea how much of that we are mixing in, but we do know that if we mix in X ounces and 20 ounces, all together we will have X plus 20. Think of a bucket, dump in X, dump in 20, how much is in the bucket? X plus 20. So here we go, 0.73X plus, I want to say 6.8, but you know what? I don't know. I don't trust my arithmetic. Yeah. Equals 0.6x plus 1.2. No. Okay. So let's see what we've got here. 0.13x equals 5.2. Oh, this is going to work out nicely. I must have taken this problem out of a book or something. X equals 40. So we need 40 ounces of the 73% juice to end up with a 60% solution. Amount times percent equals amount times percent, and then just solve it. That's easy. Okay, now we got a cylindrical tank. Has a 15-inch diameter. So I'll draw a little picture here of my cylinder. Here's my cylindrical tank. And it has a 15-inch diameter, which means its radius is 7.5. The water in the tank is 20 inches deep. So this is 20. Okay, then we're going to start losing some. We're going to open the drain, and out's going to come the water at a rate of 2.5 cubic inches per minute. So write an expression for the volume of water, T minutes. So T is going to be the number of minutes the drain is open. And there we go. We want an expression for the volume of water. Now, if you just think about this, I know, you guys look at this, you read this problem, and you just get terrified. It is so simple. You got water in the tank right now. You're going to open it up and let some out. to find out how much is left, you're going to take what you have in the tank at the beginning and subtract what comes out, right? I mean, that's a very simple concept. So how much water's in the tank right now? At the beginning, I mean, before I open the drain. Well, volume is pi r squared h for a cylinder, and I know everything. I know the radius is 7.5 and the height is 20. So the water that's in the tank right now is 1125 pi cubic inches. That's how much water is in the tank when the problem begins. So you're going to take 1125 pi and you're going to subtract the water that's coming out. Well, how much water is coming out? 2.5 cubic inches every minute. So how will we express that? 2.5 every minute. That's 2.5 T. And that is the answer to the question. So if you left it open for 10 minutes, you would lose 25 cubic inches, and you'd have that minus 25 left after 10 minutes. If you left it open for 100 minutes, you'd have 250 cubic inches gone, so you'd have 1125 pi minus 250. That's how much water would be left in the tank. And finally, is the square root function 1 to 1? Why or why not? Well, I think you need to visualize the square root function. The square root function, remember, looks like this. To be 1 to 1, you must pass the vertical line test and the horizontal line test. To be 1 to 1. Does this pass the vertical line test? Yep. Does it pass the horizontal line test? Yep. This is 1 to 1 because it passes both the vertical line test and the horizontal line test. That is a 1 to 1 function. Okay, that's it for that sheet. That's done. I'm just looking at these other things, and I don't see anything that I don't see on that sheet, except there is this one question that says something like, if f of 2 is 7, then f inverse of 7 would be what? Well, remember, this is the ordered pair 2, 7. This is just another way of writing an ordered pair, 2, 7. The inverse would be 7, 2. Remember, if they are inverses, then their ordered pairs switch. So if 2 becomes 7, then that 7 is going to become a 2 if they're inverses. All right, that's that. Good luck. Have a great weekend.